thank you for coming tonight. We have a really good speaker tonight with some good information for you. I want to especially welcome our high school seniors from the government class. Our future, it's important that you're here, and we're glad that you're here, so welcome. With that being said, I have the great pleasure of introducing our guest, and Robert Rice, known to me as Bob, and he is a retired U.S. Forester Service Supervisor, and he also happens to be the President of the Board of Trustees of COS. Would you please help me welcome Bob Rice?
Thank you, Louise. And thanks to everybody for coming tonight. I think you might find what I have to say about the Klamath River kind of interesting. A special thanks first goes to Harry Lake. Harry helped me quite a bit with my graphics, and I really appreciate that. And I thank Paul McKenna, all sitting there in the back row. Stand up, Paul. You did a wonderful job. When you get into this kind of a conversation, you load yourself up with a lot of graphics. I also wanted to identify the fact that there are 3 foresters in the room, and I really appreciate that. Ray Hopp, sitting back here, who's running for county supervisor. And this other guy said I shouldn't introduce him, but I want to. Jerry and I spent a lot of time together looking at places to cut trees, and a few other things. I was a little tough on him, but he's forgiven me. My story tonight is a personal overview, an overview of what I, as a resource manager and a public administrator, should have knowledge of if I'm going to make some watershed decisions for the Klamath Basin. My training and experience in resource management would cause me to take a holistic approach as I looked at all of the activities and the needs in this particular area. The prism that I look through when I look at the possibility of exercising an action back when I was working was quite different than the 26 stakeholders that have utilized in designing and authorizing the Klamath Basin Restoration Agreement and the Klamath Basin Hydro Settlement Agreement. 62% of the Klamath Basin public land, and agencies are required by the National Environmental Policy Act to do a thorough analysis and report out actions. 38% of this basin is managed by 9 local community districts, specifically counties, and they too must be totally involved in any kind of actions that have to occur when you're talking about those 10 million acres. I would share with you that I'm very uncomfortable for all of the government agencies, non-government organizations, tribes, public utility, and a scattering of stakeholders that have willingly pursued agreements using a very limited self-ordained knowledge, personal philosophies, and my checkbook and yours. They're going to spend inflated $3 billion on an experiment. When you look at what's going on in the 10 million acre area, know that relationships are interconnected. Water is interconnected, fish are interconnected, the plants are interconnected, and on and on and on. But we have what we would call a warm water river, enclosed by 10 million acres of terrain, tributaries, animals, and plants, with a wide-ranging climate and a rich mosaic of landscapes. It's a special place. And to live and it presents a huge challenge to keep what we have and what we want. I'm going to talk a little bit about the governor of this 10 million acre watershed. The Pacific Ocean, right here, is the governor of what goes on in the entire 10 million acre basin. What happens in the ocean, dictates what happens to our water supply and what happens to our fish. It's an upside down watershed. And because it's an upside down watershed, what happens is, if you visualize for a minute, what happens is through an activity I would refer to as evapotranspiration. Look at it as a bucket, a big bucket of water that goes out into the ocean and dips up 200 inches of water, okay? When it dips up those 200 inches of water, it starts dumping them in this particular basin where you have the mountains, and it starts dumping right here, and periodically it'll dump 90 inches here, it'll dump 50 or 60 inches here, it'll dump 40 inches here, and by the time it gets to Rico, there's only about 20 inches left in the bucket. It dumps, or 40 inches left in the bucket, it dumps a little bit there, and then as it moves all the way up to Klamath Falls, there's only 10 inches left in the bucket, and it dumps it there. Now you know, as you look at the colors of the watershed, why this is so light colored and why this is a darker green. It's simply because of the relationship between precipitation and the moisture that falls to the ground. Very important point when you start thinking about the different things that have to be considered when you manage this kind of a work. Climatologists have discussed evapotranspiration a lot, but they haven't publicized it very much. And it's a pretty important action that we have to put up with. The other side of the coin is what oceanographers talk about. Oceanographers talk about subsurface activity. Volcanic bursts and earthquakes are where they look. And what happens when you have the volcanic bursts and earthquakes, you have a change in the ocean temperature. And when you have a change in the over temperature, there's a period of time when it starts from a warm side and starts getting cooler and advances over a 10-year period. And what happens when the ocean gets cooler is more food is produced and more salmon live. And what happens when they live, they also get bigger. And we've experienced this year the fact that salmon are usually on a 4-year cycle, but this year, half of the population that came into the estuary were 3-year-olds. So what that tells you is through the food process that's going on, the 3-year-olds are starting to mature a little bit early, and the combination of 3-year-olds and 4-year-olds caused the population to almost get to 700,000 fish, which was the in-river run. The term that is used by oceanographers is PDO, Pacific Decadal Oscillation. And what that essentially says is the temperatures change somewhere in about a 10-year cycle. You've heard of El Nino, you've heard of La Niña. That's the kind of things that happen in the tropics. Very similar to what goes on in the Pacific Ocean, but that particular opportunity is over a 30-year period. The interesting thing about the ocean is the fact that people don't quite realize what goes on out there from a standpoint of the predators, the seals, for instance, and what goes on out there in harvesting the fish. In 1950, 25 metric tons of salmon were harvested in the ocean by ships, not only from the United States, but from different countries. One of the ships is called a sake ship. It's equipped on the ship to go all the way through from catching fish to canning them and producing dog and cat food. Another opportunity is what we call the Russian vacuum ships, And what they do is they have a way of vacuuming fish off the bottom of the ocean. Russian trawlers don't work very far from the coast of the United States. The third thing that goes on out there is the Asian ships, and they have drift nets. And I don't know if any of you have seen the drift nets, but look at how small the size is with those drift nets. A ship can put out 40 miles of drift nets. Can you think about how many salmon are caught in 40 miles of drift nets? A lot. So, remember two things. Remember, number one, the governance of evapotranspiration on our water, and remember the activities in the ocean that change the temperature and determine how many fish enter the estuary and eventually move on up the river and finally end up at the hatchery, some of them. I've divided the segments tonight, 7 of them, that I want to talk about a little bit shortly. But I do want you all to take the opportunity of seeing what 300 miles goes through and enters up, and believe it or not, Crater Lake is in the basin. Crater Lake sits about up here somewhere. It's in the basin. And by the way, Crater Lake is the only national park in the state of Oregon. I don't know how many of you knew that. I didn't know it until I started working on this particular document. In the estuary is 2.5 miles long. It covers probably about 1,000 acres. Can you imagine what it would be like in that estuary if 700,000 adult fish entered it all at the same time? We're fortunate that salmon come into the estuary, and they likely come in through high tide, and they come in at different time as schools. So that's the good thing about knowing what goes on in the estuary. Take a chance and take a look at the estuary. It sits right here, and the mouth is surrounded by Redwood State Park, and it is a place where adult salmon spend a short period of time, maybe a month or 2 months. I don't know for sure, I'm not a biologist. And their job when they're in the estuary is to adapt from the ocean environment, saltwater, to the river environment, freshwater. That's the job of the estuary. And they don't leave the estuary until something triggers their movement. And what can trigger their movement is a flux of cold water that comes down either from Iron Gate Reservoir or from Lewiston Dam up on the Trinity. Now, one of the things that have occurred this year for sure, is that the Hoopas have what they call an Indian boat dance. And the Hoopas know that by releasing cold water out of the Lewiston Dam or the Trinity Dam, whichever one they work with the BOR, Bureau of Reclamation on, that brings cold water down the Trinity River into the Klamath River. And when that occurs, the salmon then get the message, it triggers them to leave the estuary and start working their way upriver. 2 events have occurred in the past. One, as you know, is the Bucket Brigade. Some of you may have participated in it. Others you would know. In 2002, we had 34,000 salmon die, and they died in the next segment that I'm going to talk about. That's the segment that runs from 2.5 miles up to 44 miles. That's river mileposts. And that particular segment has a 1-mile border that is UOC property, and a portion of it has the 12-mile square Hoopa reservation. There's also a little 238 ranchera on the river, and that is the Reganini tribe. And those are essentially the three shoreline tribes that are in this particular segment. So take a look and you can see what the 43 miles look like. This is about the most popular fishing opportunity there is on the Klamath River because number one, the fish are still nice and silver. Number two, relatively easy to catch in this part of the world if you get permission. And number three, there's a lot of activity in this for what we call gill netting. So quite a few things go on in this particular part of the world. I don't want to forget, and take a look at this if you get a chance, what Clare Angle Reservoir looks like. Not many people in this room realize that Clare Angle Reservoir is in the watershed. Clare Angle Reservoir has on it Trinity Dam. It also releases water to Lewiston Dam. Both the Trinity Dam and the Lewiston Dam are high power generator facilities. The Lewiston Dam produces 340 megawatts of electricity. That's twice as much of electricity produced as is produced on the 4 dams on the Klamath. I can't tell you exactly how much is produced at Trinity Dam, but I'll bet you it's more than 340. So take a look and recognize that for each megawatt of electricity, that's an income of about between $700,000 and $800,000. Lots of income. Probably the biggest income producer in the Klamath Basin. I want to move on and I want to talk about my next segment, my third segment. Third segment is one that a few of us are quite familiar with, and that's the segment that it covers all of the public land. This segment runs from milepost 44 all the way up to milepost about 142, starts at Wichita Bridge, ends up just before Scott River. Essentially all covered by national forest land. And what's so interesting about this piece of territory in the Klamath Basin is that there are 106 tributaries, 106 tributaries putting water into the Klamath River. And this area, this section of land, has the best water quality in the entire Klamath Basin. It's good news for us two foresters because we worked hard under the Clean Water Act to make sure that we were putting the right kind of water into the Klamath River when we were harvesting timber or building roads or doing the kinds of things that we do under a multiple use responsibility. Clean Water Act I mentioned. I wanted to indicate to all of you that about 200,000 board feet of timber, which is almost equivalent to the growth, maybe a little less than the growth, has been harvested off of this part. In the mid-'80s, 7 sawmills were dependent on what we produced in this part of the world. And under the Payment in Lieu of Taxes Act, the Forest Service contributed $7 million a year to the county for roads and schools. There's a guy sitting here in the audience that received that check quite frequently. Did you spend it all, Frank?
I'm just looking for it every month.
I wanted to also mention one other thing, and that is, and there may be a couple people in the room that will disagree with me, but that's okay. This land, the national forests, come under the Federal Reserve water right. And what that says is that if water originates in this land, it stays within the ownership of that land while to take care of what that land was proclamated for. If it was proclamated for water supply, if it was proclamated for fish improvement, if it was proclamated for growing trees or whatever, that particular water right stays with the national forest and it's not subjugated to the state water law. Not subjugated to the state water law. One other point that I want to mention And that is in 1987 and 1988. Back in the good old days, I had some really good fisheries biologists that I worked with. And we decided to go ahead and do a habitat study for salmon. And we explored quite a few of the tributaries on this area that I'm talking about, those that that get salmon for spawning. We examined that pretty close, and during the 2 years that we looked, the in-river population that we dealt with was about 150 to 160,000 salmon that were coming up the river. The second year, it was about 200,000 salmon. So we had a pretty good sense at that point in time what kind of use we were going to get in the tributaries and the rivers from the standpoint of spawning. We found that there were 21 different habitats. 5 of those habitats I refer to as primo habitats. And in those 5 primo habitats, that's the first place they want to go. That's the ice cream nesting place, if you will. They go there first, and what we found out was in the primo habitats, different ones on the river, the nesting, or reds as we call them, amounted to about 40% of the available choices. It's not very many. 40% was used when the population of salmon was between 140 and 200,000 spawners. There's a lot of room left to lay a few eggs. Back again to what I talked about earlier, this particular area has a precipitation range of somewhere between about 40 and 60 inches per annum. Very, very important part of the Klamath River Basin. I'm going to go to segment 3, where most of us here live. It's an interesting part of the world, and I refer to this segment as the Tri-Valley segment. It's an area where we have 3 valleys: Scott, Shasta, and Butte. This particular area, I've only shown where it borders the river, but it curls around here and goes all the way up to Doris. So it gives you a pretty good idea. It's a lot of acreage, but a very short border to the Klamath River. 9 cities, a couple of community service districts, and a lot of people that depend on agriculture and forest products for their livelihood. It's our community vitality, and very important part of the activities that go on in the entire basin. There are some interesting points that I want to talk about. First of all, as I approach this part of the world, I want to pass on to you that we're now into the precipitation range of about 17 inches per year. And you can start seeing the relationship when you start getting into the lower precipitation rate. Take a good look, because you see how light colored this is? The precipitation rate from this area right here through the 3 valleys runs anywhere from 17 inches to about 10 at Klamath Falls. So what does that tell you? You want to do something about water? You got to have some storage facilities. Water storage facilities. And our partners, a long time ago, realized this back in the 1900s. And what they ended up doing is they put a series of dams in to catch the water when we were in this low precipitation zone. I pass on to you that I talked about 2 dams in this part of the world. I now want to talk about 70 more in this part of the world. Big difference where you find the dams and where you don't find them. Part of the dams in this part of the world, this particular segment, are streamflow maintenance dams. There's 37 streamflow maintenance dams They were constructed by the CCCs and built for the purpose of catching the snowmelt and delaying it in its efforts to go down to the Scott River. So what that did, that would generate more water for the Scott River. This particular plan that was done for this part of the world was conducted in partnership between the Bureau of Reclamation and the State of California Department of Water Resources. Some of the dams have been repaired, but not very many, and it's unfortunate because they could contribute, if they were alive and well, to an additional maybe 2 or 3 second feet to the Scott River, and the Scott River needs water. One other point that I wanted to make is that in this particular part of the world, there's another authority, and that authority is called the Siskiyou Power Authority. You know, how many people know about the Siskiyou Power Authority? But the Siskiyou Power Authority runs Lake Siskiyou Power Generation Plant. Lake Siskiyou Power Generation Plant produces 4 megawatts of power. The income to Siskiyou County for that 4 generation of power is $2.5 million. Think about the possibility of having a few more and what the income would be for this particular county. Think about it. I think I've covered everything except one thing, and that is the Bi-State Compact. I'm a student of the Bi-State Compact. I can answer questions about it later if you wish. Just want to share with you that one of the principal things about the Bi-State Compact was that it set the priority of uses for water in the entire Klamath Basin. Priority number 1 is domestic. Priority number 2 is irrigation. Priority number 3 is fish, wildlife, and recreation. Priority number 4 is the production of hydroelectric power. Number 5, interesting enough, is flood control, to make sure that we have the right storage facilities for flood control. Now, in that little blurb about the 5th priority, it also talks about navigation. Not a whole lot of navigation going on in the Klamath River, as you all know. I forgot to mention the Lewiston hatchery in the other segment. It produces 1 million fingerlings and juveniles per year. It releases them into the Klamath River. We now have the Iron Gate hatchery in this particular segment. The Iron Gate hatchery produces 6 million fingerlings per year. And the combination of the 6 million fingerlings that come out of Iron Gate and the 1 million fingerlings that come out of Lewiston, and not counting the natural fingerlings that are produced in the Scott and the Salmon rivers and other rivers, work their way in the spring down to the estuary. And when they get to the estuary, their purpose in life is to convert from freshwater to saltwater. I don't know how long they stay to make sure that they smolt to the point where they become adapted, but it's somewhere in the neighborhood of about 2 months. So then, when they get down to the estuary, they turn to silver. And the reason they turn to silver is because that's the camouflage for them when they get in the ocean. Makes sense. So the estuary really plays an important part for the adult salmon to come upriver and the fingerlings to go to the ocean. Remember, the 4-year cycle of salmon is 4 years. When you add up the time that the adults spend in the river, some are still there, and the fingerlings spend in the river, you probably have used up 9 months. So of that 4-year cycle, salmon spend about 9 months in the Klamath River and its tributaries. The next segment, currently the most popular segment, is the segment that runs from River Mile 191 to River Mile approximately 226. In that River Mile section, there are 7 hydroelectric power plants. Iron Gate, the 2 Copcos, J.C. Boyle, Fall River, and 2 on Lynx Dam. They call them the west side and east side. The productivity of those particular facilities is 169 megawatts per year. Compare that for a minute to what goes on in Clare Engle and Lewiston. A big difference. But now think back to the fact that, hey, hydro energy generation in this part of the world is a big moneymaker. So how much do you think the franchise is worth to the county for paying for the income that they receive from the standpoint of power generation, power transmission, and power distribution? Power, in this particular case, the transmission goes, or the generation goes to the transmission lines. Transmission lines send power to 8 counties in the basin and 1 county outside of the basin, Shasta. The generation that occurs in the Lewiston Trinity Dam goes directly to the valley, Sacramento Valley, and maybe a little bit further south. Pretty important. The map on the power lines is pretty available, but I want to get back to my train of thought here and indicate to you that Siskiyou County receives a franchise with Pacific Power. This year, the receipts were $190,000 for the opportunity to distribute power to all of us that get Pacific Power from the company. The way that franchise is computed is on the number of miles of distribution line that are available in Siskiyou County. And that computes to 600 miles. So there's a formula that says because they have the right to distribute through 600 miles of distribution lines, they pay an income of $190,000 in 2013. This contract was developed in 2004, and it runs till 2020. What happens in 2020? Think about it. One of the things I want to talk about that's very significant to this part of the river is the fact that those dams, primarily Copco and J.C. Boyle, were built on basalt reefs. And when you look back over time, one of the reasons that they get into conversations about removal of the dams in the agreement is because they feel that by removing the dams, the fish will go all the way up the river, through Lake Ewana, through Upper Klamath Lake, which I now call a reservoir, on up to the rivers, Sycam, Wood, Williamson, and Spring. So the governors, when they had their big speech of removing the dams, said, by doing that, we'll add 350 miles of spawning for salmon. There's a study out, and the study says that after salmon travel about 200 to 250 miles, their shape changes, and their shape changes to look like a torpedo. That's to kind of keep going further. But what happens when their shape changes to a torpedo is that the only way they can survive is to eat the eggs in their body. So even though, and by eating the eggs, that's their energy supply to continue to move up to a location where they supposedly want to lay the eggs. Sorry, folks, there's a distance here that you've got to think about. What had happened over time since 2008, the California Fish and Wildlife Service, located in Wairika, put out a study, and in that study they said, we got to remove the dams because we want to make the migration route back to the historical level, which they claim, showing us pictures that occurred in Williamson, Sprague, and the Wood, and others. I have a good friend, two people in the audience that know him very well. That's Jim Rock. He was my archaeologist. He did a lot of study in the upper part of the basin, and in that study, one of the things they did is they had some digs. And in the digs, they did find what they believe is evidence of salmon. Not very many, but what they found out in the digs is that none of the salmon that they found had head bones. Heads were gone. Now, we can speculate a lot about that, but one thing we can say is that maybe they were transported for food, and they were transported for using the lightest weight. The lightest weight had to be without the heads. So that's one of the thoughts that we've been playing around with. Now we turn around again, and the California Department of Fish and Game shared with us in a study produced back in the late 30s, where they said salmon migrated to River Mile 220. River Mile 220 is just about where J.C. Boyle Dam is, Bob. And they didn't go up Spencer Creek. So what was so interesting about that study by Fish and Game is there's a direct disagreement between the California Department of Fish and Game and their historical review of where salmon went and Fish and Wildlife Service. Direct disagreement. Yet the agreement, the people, the 26 stakeholders, took the Fish and Wildlife document and said, we've got to go ahead and move the fish all the way up to the three big rivers. I'll talk about a little bit for a minute about the two reservoirs, Iron Gate and Copco. Iron Gate is about 58,000, holds about 58,000 acre feet. Copco holds about 77,000 acre feet. What's the purpose of Iron Gate? It's got four purposes. Purpose number one is to make sure there's a minimum stream flow in the Klamath River, because that's the way that the salmon can get to the hatchery. Very important. The next responsibility, obviously, is to retain water when we have a wet water year, so that we don't have the flooding opportunities coming down the river. Another possibility, obviously, is to generate power. And the third possibility, or the fourth possibility, is to go ahead and satisfy cool water into the Iron Gate hatchery. So four purposes going on with Iron Gate hatchery, or Iron Gate reservoir. Copco's got a different responsibility. And that, when Copco was built, Iron Gate had to be put in because of the power surges that go on as a result of generation at Copco. But Copco's other interesting responsibility is that from all of the development that goes on in the upper Klamath Basin and some of the activity that goes on in the project, the BOR project, a lot of silt's generated. That silt flows down the Klamath River, and fortunately, it's collected by Copco. Studies indicate that Copco, help me Bob if I'm wrong, but studies indicate that Copco has about 20 million cubic yards of silt deposited there. And it's very important that the deposit is there, because when it's gone, that's going to move down the river, and you can all guess what might happen if that occurs. The next particular segment is the segment that deals with the Bureau of Reclamation's project. 238,000 acres of farmland in refuges. The refuges are foreign. So there's a great dependency on water coming out of Upper Klamath Lake Reservoir to be fed into the project. The project is limited on how much water it can take, and the limit that is imposed upon them by the Bureau of Reclamation is 400,000 acre-feet per year. I'm going to give you a few statistics here in a minute, but remember, 400,000 acre-feet goes to the project. In the year 2010, there was a low, almost a drought water year. The projects, the BOR told the project people, we're reducing the flow of water to the project. You're only going to get 30%. 30%. And what that caused, when that occurred, well, in order for the farmers to continue to grow crops in the project, they had to go to deep well pumping. They have 12 deep well pumps, so they have an opportunity to feed their projects. The Keno Dam in the project is the dam that collects water from the project. And it regulates the water that flows down the Klamath River, because it has an opportunity to mix the water that comes from Upper Klamath Lake with the water that comes from the project. So what Keno does, and Keno incidentally is owned by Pacific Corp, what they do then is they can release the water to keep an even flow to meet needs, depending on what time of the year they have to meet them to keep the flow in the Klamath River. The other key important part of this particular segment is Lynx Dam. And Lynx Dam was built on a reef. So it was raised a little bit, but remember, there's a reef. So we now have discussed the reefs at Copco, the basalt reefs at J.C. Boyle, where it was built. And what that all leads to is that the location where all of the impoundments and hydroelectric power facilities were built is a long, narrow canyon. And there were good opportunities to put in hydroelectric facilities because of the narrowness of the canyon and the fact that they had some reefs where they could expand and collect water through impoundments. A couple of other things about the Lynx Dam, and one of the things is that that's the key diversion point for the project, and that's called the A Canal. And the A Canal then is the major canal that feeds water into the project. But there are 4 other canals further down the Klamath River. One serves as an opportunity to take the tailwater from the project and dump it back into the Klamath River. The other 3 opportunities are possibilities for extracting water to serve some of the refuges. But remember, the objective is to not exceed 400,000 acre-feet. That's the limit. Lost River also serves the project. Klamath River out of Upper Klamath Lake Dam sends water in, but there's also a part of the project that collects water from Lost River, a little bit to the east of the Klamath River. And totally, I can't tell you right at the moment how much water goes into the project from Lost River, but I can tell you that in the total project area, there are 10 pump stations, many, many miles of canal, and some impoundments. And the project was constructed, my recollection is 1906. I call this particular part the in-river adjudication, tri-river adjudication, if you will. Water comes down those 3 rivers and comes into Agency Lake and Reservoir and then drops down into Upper Klamath. Upper Klamath is 8 feet deep, not very deep, but it is an important habitat for suckerfish. And the Klamath Indians control 4.5 elevation, the water level elevation to 4.5 feet. That means that the project has to get their 400,000 acres off the top 4 feet. Now, there's a problem, a little bit of a problem with Upper Klamath Lake and Lake Ewanna. They're classified by the Department of Interior as hydroeuphoric lakes. High in nutrients, low in oxygen. Maybe a few other chemicals mixed in. When people started talking about moving the salmon all the way up into those 3 rivers up above, because of the conditions of Upper Klamath Lake and Lake Ewanna, right here, the thought process would be that we will truck and haul salmon from a point, probably J.C. Boyle, take it all the way up and dump it into the 3 rivers. My question, when I hear that suggestion, is what about the fingerlings? How are you going to get them back down? They're not going to make it. So this is an interesting dilemma that is starting to go on up there. The first thing I wanted to mention is that there are 13 hydrologic units in the Klamath Basin. Nobody pays any attention to that. That's the key. That's the way that water resources have been identified in this particular part of the world. The Williamson, Wood, Sprague, and Sycamore and Lost River annually discharge 2 million acre-feet of water. 1,600,000 acre-feet flow into Agency Lake. The annual precipitation in this part of the world is mostly 12 inches, but because of some of the relationships to Crater Lake and the snowfall, it may go up as high as 32 inches. Recent court rulings have occurred up there, and the recent court rulings that have occurred up there have indicated that historically the Klamath Indians control the flows and the water in Upper Klamath and Agency Lake. We'll hear more about it, but that's going to put an impact on the off-project farmers because they have to take irrigation water from those 2-3 rivers. So a lot of negotiations going on, and I can't tell you at this point what it's going to look like. 2 national forests, a national park, 3 refuges, 1 reservation, and the off-project are pretty much the ownership in this part of the world. There is an export of water out of the Klamath Basin here. 4 Mile Creek, which puts water into Upper Klamath Lake, has a reservoir on it that prevents a amount of water that can come into Upper Klamath Lake and is transmitted to the Rogue Valley Irrigation District in Oregon. So I've given you 3 exports of water, and the 4th one is Jenny Creek. And some of you have traveled up there and have been acquainted with. They are both reservoirs that take water from the Jenny Creek drainage and transmit it into the Rogue Valley Irrigation District. So BOR has been pretty active in this whole Klamath Basin situation. They got their flagship project, 238,000 acres, right there in Tule Lake. They've got an export program for Rogue Valley Irrigation District out of 4 Mile and Jenny Creek. That's pretty much 2 projects. They've participated in doing something to augment the water that hasn't been accomplished for Scott River. And they have managed to put together an export facility out of Claringle Lake using the two dams, Trinity Dam and Lewiston Dam. Upper Klamath Lake Storage Facility has a capacity of 500,000 acre feet. Remember, I mentioned that there was a pretty good production from the rivers, but also remember that Klamath Lake's a pretty shallow lake. 210,000 acre feet are lost in that lake through evaporation. Big chunk of water. I mentioned the 8-foot depth. I mentioned the 4-foot. I mentioned that hydroeutrophic was a classification initiated by Interior Department. I mentioned the fact that 400,000 acre feet are distributed to the project. Largest city within the basin is Klamath Falls, 70,000 people and growing. Headquarters for the Klamath Compact Commission, by law, have to be in Klamath Falls. But the commission has a responsibility to cover the whole Klamath River. When you look at the amount of water coming in, and you look at the amount of water taken, and the amount of water that's evaporated, the cubic foot per second flow out of Link River, which is the flow that goes into the Klamath after the A Canal, is 1,395 acre feet. So what now you know that right there at the beginning of the Klamath River, River Mile 252, the flow of water into that river is essentially that amount. More could be added if tailwater came out of the project. So there it is, the importance of water. And I want to go back here and just reiterate a minute, and then I want to give you my abstract. The two important opportunities are that what happens in the ocean controls how many fish come into the estuary. And what happens in the ocean, scooping of water into the clouds and depositing it, happens in the ocean. When I look and read the KBRA and the KHSA, I find no mention of what goes on in the ocean. Now you know why I'm doing everything I can to indicate, based on my experiences and training, that the way the 26 stakeholders looked at the Klamath Basin and what they want to do ignored the possibility of what goes on in the ocean. That's pretty bad, pretty bad. I did mention, and I hope I did, but we have in-run identification for salmon going back to 1961. And the lowest number of salmon that entered the estuary during that period of time, 50 years if you will, was 35,000. The highest number of salmon that entered the estuary last year was 700,000. You can't sit down and say, I want to do this habitat improvement, or I want to do that, or I want to restore this, or I want to do these kinds of things, if you don't know how many fish you're going to have coming up the river. Somewhere along the line, somebody's got to pay attention to that. And that's essentially what I want to do, is just close my multiple resource review with the notion that altering or changing the management guidelines and direction in the bi-state compact will be complex and expensive. I don't support it. A federal statute prepared in 1957 by principals from 9 counties, 2 states, and federal representatives was a well-thought-through piece of work. It needs some tinkering to encompass legal changes. It needs a local government advisory group. It needs stabilized financing and a qualified staff and an expression of support by all 9 counties. Thanks for listening. I'll take some questions.